Look at this globe. In this globe, we can see swirls or circular motion in water bodies. These swirls or circular motion represent the circulation of ocean currents. So today we will study how ocean currents circulate in the Pacific Ocean. This is a world map on ocean currents. In our previous video, we saw that the ocean currents were moving in circular manner. And in this map also we can see that the ocean currents are forming patterns. So these circular patterns formed by ocean currents is called a gyre. In other words, the vast system of rotating ocean currents is called a gyre. We can see these patterns on large water bodies like oceans. Now, if you see, the ocean currents are following a pattern or specific direction. What is this direction? Well, we have already learned that the ocean currents follow a clockwise pattern in northern hemisphere and they follow anti-clockwise pattern in southern hemisphere. We have already learned why this happens. Well, this happens due to Coriolis effect caused by Earth's rotation. We can see patterns of two colors, red and blue. The red ones denote the warm currents and the blue ones denote the cold currents. You see that the warm currents flow from torrid zone to the temperate zone. That is, the warm currents flow from a warmer region to a cooler region. And since they originate in the torrid zone which has very high temperature, therefore warm currents wherever they flow have a warm influence. Now again look at this, the cold currents move from temperate zone to the torrid zone. So the cold currents which originate in the temperate zone have a cooling influence over which they flow. So we have understood that how the ocean currents flow across the globe. Now we will specifically study about the Pacific Ocean. Now, before starting with the circulation of ocean currents in Pacific Ocean, let me introduce to you with the three important ocean currents that are prevalent mostly in the torrid zone and flows across all oceans. Now, since these three currents originate in the torrid zone which has very high temperature, all these three currents are warm currents. That is, they raise the temperature of places over which they blow. So these warm currents have a warm influence on regions over which they flow. Now first let us deal with the north equatorial current. As you can see in the image, the north equatorial current flows from east to west. Now if we look at the world map, and we divide this into two halves, the left side represents the eastern half while the right side represents the western half. So the north equatorial current flows from east to west. Now while this current flows from east to west, they deflect to the right. See, at every point they are deflecting to the right. We have already learned that this deflection happens due to Coriolis effect caused by Earth's rotation. Again, similarly, the south equatorial current also flows from east to west. Now you see that while the south equatorial current flows from east to west, they deflect to the left. Why I am saying left is that, so if you stand on the equator and face the south pole, you will find that the south equatorial current deflects to the left like this. And again This deflection happens due to Coriolis effect caused by Earth's rotation. Now you see that the north equatorial current is deflecting to the right and the south equatorial current is deflecting to the left. So a gap is created at the equator at every point across the globe. So a vacuum is created in the equatorial region. To fill this gap or to fill this vacuum, the equatorial counter current travels or moves in an opposite direction, that is from west to east. See, from west to east. So we have understood about the movement of three important ocean currents that are prevalent in the torrid zone. We have learned that the north equatorial current flows in the northern hemisphere from east to west, while the south equatorial current flows in the southern hemisphere from the equator from east to west. The north equatorial current deflects to the right in the northern hemisphere and the south equatorial current deflects to the left in the southern hemisphere. And the equatorial counter current flows from west to east to fill up the vacuum. Now we will study about the behavior of ocean currents in the Pacific Ocean. So now we will start with the circulation of ocean currents in the Pacific Ocean. So first we will study about the circulation of ocean currents in the northern part of the Pacific Ocean and then in the southern part of the Pacific Ocean. In the northern part of the Pacific Ocean, two ocean currents are very important. The first one is the Kuroshio current. The Kuroshio current is a warm current which originates in the torrid zone near the eastern coast of Taiwan. Then this current flows towards Japan. Let me tell you an interesting fact about Kuroshio current. Do you know Kuroshio current is also called black stream? Do you know why? When Kuroshio current flow in the water bodies appear to have a darker blue color than usual. That's why Kuroshio current is also known as black stream. Now let me tell you about the influence of Kuroshio current or how important Kuroshio current is for Japan. We already know Kuroshio current is a warm current. So Kuroshio current has a warm influence on Japan. The warm influence of Kuroshio current supports the coral reef of Japan. This warm water is actually very helpful for the coral reefs because the coral reefs cannot tolerate a temperature higher than 18 degrees Celsius. So the warm current like Kuroshio current is actually benefiting the coral reefs to survive and thrive. Can you name this delicious dish? Have you ever tasted it? Well, this dish is known as sushi. It is very tasty. Do you know how sushi is prepared? Sushi is prepared by rolling raw fish with sticky rice or boiled rice. So, this dish is a traditional delicacy of Japan. So, we can understand that Japan must have ample source of fishes in its own country. Now, let us look at one of those fishing grounds. We have already learned that a fishing ground usually develops at the confluence of a warm and a cold current. Now, we have already learned that the Kuroshio current, which is a warm current, flows along the eastern coast of Japan. Now, when it flows along the eastern coast of Japan, here it meets with a cold current. Now, when this cold current comes here, it brings planktons and nutrients along with it from deep oceans, and therefore a very prosperous fishing ground can be found here. Now, here we have talked about a cold current. Do you know what is the name of this current? The name of that cold current is Oyasu current. The Oyasu current is not a part of the North Pacific cycle. This cold current, that is the Oyasu current, is originally not a part of the North Pacific cycle. This Oyasu current originates in the Arctic Ocean. Now, since this current originates in the Arctic Ocean, in the polar region which has very cold temperature, therefore, Oyasu current is a cold current. Now, Oyasu current originates in the Arctic Ocean and flows southwards towards Japan. When it comes here, it meets with the Kuroshio current and develops a very rich fishing ground here. Now let's see what impact this current has on Japan. Now we have already learned that the Oyasu current originates in the Arctic region, so it is a cold current. So when this Oyasu current comes down from the Arctic Ocean southwards to Japan, it brings mass chunks of ice along with it. It even freezes the coastal regions and therefore it becomes difficult for the ships to navigate. Therefore, ice breakers are needed to make the ports navigable. One such port is the Vladivostok port in Japan. This phenomena can be observed in that port where we need ice breakers to break the mass chunks of ice which is brought down by the Oyasu current and to make navigation possible in this port. Now, before we proceed with our lesson, can you help me to answer this question? Which of the following is a cold current? Yes, the correct answer is Oyasu current. We have just read that the Oyasu current is the current that originates in the Arctic region and therefore it is a cold current. Now let us understand the complete circulation of ocean currents in the northern part of the Pacific Ocean. The cycle starts with the North Equatorial current. We have already learnt about this current. This current originates in the Torrid zone and flows from east to west. And from here, they deflect to the right due to Coriolis effect. Now, we will see what happens next. After deflecting to the right, this current flows towards Japan. Here, it is known as the Kuroshio current. We have already learned that Kuroshio current is a warm current because it originates from the North Equatorial current, which again originates from the Torrid zone. So, North Equatorial current and Kuroshio current both are warm currents. Kuroshio current further flows towards North America. See? Now, here at the eastern coast of Japan, a cold current connects with the Kuroshio current. We have already learned that the name of this cold current is Oyasu current. Oyasu current is a cold current which originates in the Arctic Ocean and then it flows southwards and connects with Kuroshio current here at the eastern shore of Japan. The temperate zone lies here between the Arctic Circle and the Tropic of Cancer. So here we know that in the temperate zone a planetary wind called westerlies are very prominent. Now westerlies flows in this direction. Now under the influence of westerlies, the Kuroshio current flows this way and then again due to Coriolis effect it deflects like this and flows as the California current. Here you see that California current is a cold current as it is marked with blue. Now why it is a cold current? Because here in this region we can see an upwelling of cold currents from deep oceans. And we know that in deep oceans, the currents are cold and denser. And therefore, when the ocean currents come from deep oceans, they are cold currents. So in this region, we have an upwelling of cold current, and therefore California current is a cold current which is found here. Now see, in this map, we have an offshoot of Kuroshio current. The name of this offshoot is the Alaska current. See, we have learned that in the northern hemisphere, the current follows clockwise pattern. But here it is not the case. The current is following an anti-clockwise pattern. Why is that so? Specifically, the Alaska current is turning anti-clockwise or rotating anti-clockwise because of the physiography of the continent here. And the name of this continent is North America. So because of the shape of North America like this, the flow of Alaska current gets obstructed and it turns anti-clockwise like this. So Alaska current is an offshoot of Kuroshio current, which is again a warm current. So now the cycle in the northern part gets completed as the California current joins the North Equatorial current. Let me reintroduce the currents one by one again. The cycle starts with the North Equatorial current, which flows from east to west. Then due to Coriolis effect, it deflects to the right and flows towards Japan as the Kuroshio current. Here from the Arctic region, a cold current named the Oyashi current comes here and meets it. Then under the influence of westerlies in the temperate region, the Kuroshio current flows towards North America. Here it gets obstructed by the shape of the landmass here and it rotates anti-clockwise as the Alaska current, and then because of an upwelling of cold current and due to Coriolis effect, it deflects this way and flows as the cold California current. Cold California current again joins this and this cycle continues. So this is the complete circulation of ocean currents in the northern part of the Pacific Ocean. Now we will look at the story of the southern part of the Pacific Ocean. Now let's start with the circulation of ocean currents in the southern part of the Pacific Ocean. In the southern part, the cycle begins with the South Equatorial current. We have already read about this current. South Equatorial current is a warm current which originates in the torrid zone and it flows from east to west. And due to Coriolis effect, the current deflects leftwards. What happens after deflection? After deflection, the current flows towards Australia and it is known as the East Australian current. East Australian current is again a warm current because it originates from South Equatorial current, which is a warm current as it originates from the torrid zone. So South Equatorial current gives birth to another warm current, which is the East Australian current. The East Australian current comes under the influence of west wind drift. Now west wind drift is a cold current in the Southern Ocean. You can see in the image that the west wind drift almost flows in a straight line from west to east. Now why does it flow straight? Unlike other ocean currents, the west wind drift flows straight because there is no landmass in the Southern Ocean to obstruct its flow or to obstruct its path. Therefore, there is no deflection. Now we will see what happens when the East Australian current comes under the influence of west wind drift. Well, when the East Australian current comes under the influence of west wind drift, it gives birth to a new current which is called the South Pacific current. Now you see that the South Pacific current is marked with blue, which means that it is a cold current. Now why it is a cold current? Well, the East Australian current was a warm current, but under the influence of west wind drift, it turned this way. So west wind drift is a cold current, and therefore South Pacific current is also a cold current. So East Australian current was a warm current. Under the influence of west wind drift, which is a cold current, it continues as the cold current named South Pacific current. Now South Pacific current travels this way towards South America, and we will see what happens next. The cycle in the South Pacific Ocean gets completed when the South Pacific current turns this way. Now why does it turn this way? The South Pacific current turns this way because now it has reached the temperate zone, which lies between Tropic of Capricorn and Antarctic Circle. Now we know that just like in the northern half, in the southern half also a planetary wind called the westerlies is prevalent in this region. Now westerlies flows in this direction. So under this influence, the South Pacific current also turns this way under the influence of westerlies, and it gives birth to another cold current, which is called the Humboldt or Peruvian current. Another cold current which is called the Humboldt current or Peruvian current. Now Peruvian current joins the South Equatorial current, and the cycle in the southern part of the Pacific Ocean gets completed. Let me again explain you the circulation of ocean currents in the southern part of the Pacific Ocean. The cycle starts with the South Equatorial current, which flows from east to west and then deflects to the left due to Coriolis effect. Here it flows as the East Australian current. Now South Equatorial current and East Australian current both are warm currents. Now East Australian current, when it reaches New Zealand, it connects with the west wind drift. Under the influence of west wind drift, the East Australian current flows this way, and here it is known as the South Pacific current, which is a cold current because it originates from the west wind drift, which is a cold current. Now here, under the influence of westerlies, when it reaches Chile, it turns this way and it gives birth to the final cold current, which is called the Humboldt current or Peruvian current. Peruvian current again connects with the South Equatorial current, and the cycle gets completed. So today we have understood how the circulation of ocean current goes on in the northern part and the southern part of the Pacific Ocean. So today we have studied about what is a gyre. Gyre is a vast system of rotating ocean currents. Then we have studied about three important ocean currents in the torrid zone, which is the South Equatorial current, North Equatorial current and Equatorial counter current. Then we have studied about the circulation of ocean currents in the northern part of the Pacific Ocean and in the southern part of the Pacific Ocean. In our next video, we will look at the circulation of ocean currents in the Atlantic Ocean. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.